Hi folks, just response to a bit of explanation for a couple of questions in 7E, Year 1 Pure. Question 3, well I need to, question 4. Prove that all cube numbers are either a multiple of 9 or one more or one less than multiple of 9. So that's 3 conclusions I need to make. So I need 3 different types of number to cube. Now of course, all numbers are going to be either a multiple of 3 or one more than a multiple of 3 or 2 more than a multiple of 3. And of course, 2 more than a multiple of 3, I could also have said 1 less than a multiple of 3. Or indeed, I could have said 2 less than a multiple of 3. So if I consider a multiple of 3, 3n cubed is 27 n cubed. Well, of course, that's 9 lots of 3n cubed. So it's a multiple of 3. If I consider one more than a multiple of 3, 3n add 1 cubed is 27n cubed plus 27n squared plus 9n plus 1. Well, that's 9 times 3n cubed plus 3n squared plus n plus 1. 1 more than a multiple of 3. Now, I can either consider 1 less than a multiple of 3 or 2 more than a multiple of 3. And both work, and I'll show you that both work. If I do 2 more than a multiple of 3, I've worked this out actually, I worked it out on the previous page. Let's have a look. 27n cubed plus 54n squared plus 36n plus 8. Yeah. Well, that's 9 times 3n cubed plus 6n squared plus 4n plus 8. And of course, this must be 1 less than a multiple of 9. Just realised I've written 3 for those two. There you go. 1 less than a multiple of 9. If I'd chosen 3n minus 1 cubed, 27n cubed minus 27n squared plus 9n minus 1. And if I take out my 9 again, can't talk and work at the same time. I can see that it's 1 less than a multiple of 9, so I don't need both of these. But the question I was asked was, well, how do I know to look at my multiples of 3? And the answer is, because there's 3 things that I need to prove, either multiple of 3 or 1 more or 1 less. So how do I represent all my numbers as one of 3 things? The other question was question 9. Well, this is one of those things where in the book they talk about do your workings and then work backwards. Let's just see what happens. I'm going to assume that this is true. And what I'm going to do is I'm going to follow a load of steps, each one that can't be disputed, and end up with a valid conclusion. And therefore, if my conclusion is valid, my initial assumption is valid. So I'm going to assume that it's true, make some mathematical steps, come to a conclusion that's fact that can't be argued with, and since my conclusion is true, this must be true. What shall I do? I'm going to square both sides. So P plus Q squared is greater than 4PQ. Because if P and Q are both positive, it's true. So P squared plus 2PQ plus Q squared greater than 4PQ. If I take 4PQ from both sides, P squared minus 2PQ plus Q squared is greater than 0. And that's a perfect square, so I could do that. P minus Q squared. Now, this is true. Well, this is true. Anything squared is greater than 0. Okay, so my conclusion is true. Therefore, my initial assumption must be true. Now, the way the book does this is it will now, this is my working out, and it will start with this and work backwards. And of course, this is only going to be true for positive P and Q. This step here, this last step here. Because you can only take the square root if PQ is positive. And B, stick some negative numbers in. So that's an interesting one, slightly different to how the book does it. What I've done is I've assumed that this is true, and I've made a series of logical, indisputable steps. You can't argue with the maths of any of this, and since this final line must be true, anything squared is greater than 0, then my initial assumption must be true. Okay, think that's it. Yeah, let me know if you need anything. Ta-ra.